This is the introduction to the video. So I measure smoke, and I'm about the best that I know of at measuring smoke. So I do these videos to, one, work with a team at a university. So a lot of the content is pretty high level for science. But I also want to make the videos entertaining. So I use a fire backdrop and I'll put some music in it. This is one of the smoke measurement devices, and this is one of the receiver modules. And you need both of those to do this type of testing. And I'm using not these units, but the predecessors to those units. So enjoy the graphs. This is a new graph I tried. It takes the computer a long time to make this graph. I don't think I'll be doing it often. This is opacity and color shift. It gives you an idea that there's a larger transition in the color shift in simple units than opacity. Opacity is 0 to 100. However, color shift is not, shall we say, restricted to 0 to 100. So it can go up to any value. This definitely shows that the peaks occur at the same time as the high opacity levels. However, the value can change either more or less than the opacity changes. This is 8 hours of run with opacity and color shift. Again, the same data I just showed you. However, you can see that opacity at 0.3 hours goes to 50% and then wanders down to almost 0 at about 0.8, whereas color shift kind of hangs in there a little longer. It goes a little higher and then it comes back down to almost 0 about a few seconds after, or a few minutes after. Well, I want to commend a team member who helped me get this graph together. This is a Python code that one of the team members put together, and any errors were on my part. So this is a representation of a 24-hour test and the color shift and opacity for the duration of that test. So there's some 5,000 data points on this test per line. And the system plots it out quite well. So you can see that opacity and color shift tend to move together, but to different levels. And this is a nice graph done, really helps us out. So I want to say thank you to that team member. He knows who he is. This is a chart showing wavelength and incident light for the first 8 hours. So in this case, incident light is in bright pink, purple. We can see that it starts out at about 375 lux, and there's a few points where it drops down to 200 or 100. This is when smoke passes in front of the sensor. Now there's some math that goes on, but this is the raw signal you get from the sensor. The other one is wavelength, and you can see in that one where we get corresponding disturbances, we get disturbances in wavelength as well. So this is another indication that not only does smoke block the light, but it strips off some of the blue light or scatters some of the blue light. if we were to take opacity alone, this is the chart that we would see. And it does give us a great deal of information as to how much May scattering is going on, blocking light. We don't go below 0 on any portion of this test, although it does happen on occasion. I have something I did to the stove just before 3 hours that causes that tall peak. Now, if we look at color shift alone, it also gives us quite a bit of information. And this alone may tell us how much smoke is coming from the chimney. It is measured completely differently than incident light, and therefore it is considered differently. So the next one I'm going to show you is together. This chart is opacity and color shift together, with each individual data point having a marker on it. So just before 2.7, I put something in the wood stove. It was not wood. It was something that I knew would create just a brief amount of smoke. And you can see the system's response going from somewhat near baseline all the way up to about 70 opacity and 90 for color, and then screams back down to 0. This is a good graph. This is data every 20 seconds. Well, thanks for watching. Not all science is easy to look at. Not all science is that exciting. But thanks for watching. And if I didn't say like and subscribe, would I be doing YouTube videos? Thanks again.